If certification prep is part of your plan, subscribe for new practice videos and guides every week. Visit cloudcertificationstore.com for weekly releases and complete question banks. Welcome back to the playlist. Episode 2 of 15 continues the AWS Certified AI Practitioner, AIF-C01, practice series with questions 11 through 20. Let's begin the next round. Question 11. A company wants an LLM to generate concise, feature-specific product descriptions. Which prompt engineering technique meets these requirements? Option A. One generic prompt for all products, post-edit results. Option B. Category-specific prompts with key features, format, and length. Option C. Include a wide range of features in each prompt for creativity. Option D. Fully product-specific prompts for every SKU. The correct answer is B. Category-specific prompts with key features, format, and length. Explanation. Category prompts scale across many items while remaining specific enough to guide content. Explicit output constraints bullets, word limits, tone, increase consistency and brevity. Including salient features per category preserves relevance without manual post-editing. This balances quality, maintainability, and effort. Why not option A? One generic prompts reduce precision and often yield inconsistent tone and detail. Heavy post-editing reintroduces manual effort and cost. It also makes outputs harder to standardize across the catalog. Thus, it's inefficient. Why not option C? Wide range of features per prompt overloading the context distracts the model and lowers concision. It increases token usage and can introduce irrelevant details. The requirement prioritizes concise, feature-specific outputs. Therefore, this approach is misaligned. Why not option D? Fully product-specific prompts, while precise, it does not scale operationally for large catalogs. It increases authoring time and prompt maintenance effort. Category prompts achieve most of the benefit with far less overhead. Hence, D is not the most practical choice. Question 12. A team's churn model performs well on training data but poorly on new data. Which solution will resolve this issue? Option A. Decrease the regularization parameter. Option B. Increase the regularization parameter. Option C. Add more features. Option D. Train for more epochs. The correct answer is B. Increase the regularization parameter. Explanation. Poor generalization with strong training performance indicates overfitting. Increasing regularization penalizes complexity, encouraging simpler, more robust models. This often improves validation/test performance without changing the architecture. It's a standard first step before more invasive changes. Why not option A? Decrease regularization, reducing the penalty increases model complexity further. That typically worsens overfitting and test performance. It moves in the opposite direction of what's needed. Hence, it's counterproductive. Why not option C? Add more features. More features can add noise and multicollinearity, making overfitting worse. Feature expansion should be paired with feature selection/regularization and data growth. As a standalone fix, it's risky and misaligned. Therefore, not the best choice. Why not option D? Train for more epochs. Longer training on the same data tends to fit noise more tightly. This deepens overfitting and degrades generalization. Without early stopping or stronger regularization, this harms performance. Thus, it's not a remedy. Question 13. A company building on SageMaker needs to share and manage variables features for model development across multiple teams. Which SageMaker feature meets these requirements? Option A. Amazon SageMaker Feature Store. Option B. Amazon SageMaker Data Wrangler. Option C. Amazon SageMaker Clarify. Option D. Amazon SageMaker Model Cards. The correct answer is A. Amazon SageMaker Feature Store. Explanation. Feature Store centralizes feature definitions, values, and metadata for reuse. It supports online, real-time, and offline batch stores to keep training/serving consistent. Versioning and lineage help with governance and reproducibility. This directly addresses multi-team feature sharing. Why not option B? Data Wrangler streamlines data prep and transforms but doesn't serve as a shared feature repository. It's excellent for building pipelines, not for cross-team, low-latency feature access. You would still need a feature store to manage production features. Thus, it doesn't meet the core need. Why not option C? Clarify provides bias detection and explainability tooling, not feature sharing infrastructure. While important for responsible AI, it doesn't store or serve features. It addresses different lifecycle concerns. Hence, it's not applicable. Why not option D? Model cards document model purpose, performance, and limits. They improve transparency and governance but do not manage feature data. They complement rather than replace a feature store. Therefore, they don't solve the sharing requirement. Question 14. A company needs a database service to store and query vector embeddings for conversational search. Which AWS service will meet these requirements? Option A. Amazon Athena. Option B. Amazon Aurora PostgreSQL. Option C. Amazon Redshift. Option D. Amazon EMR. The correct answer is B. Amazon Aurora PostgreSQL. Explanation. Aurora PostgreSQL can enable the pgvector extension to store and query high-dimensional vectors. It supports similarity search, e.g., cosine, inner product, for RAG applications. Managed Aurora provides operational resilience and scalability. This matches the need for embedding storage and retrieval. Why not option A? Amazon Athena. Athena is a serverless query service for data in S3, not a vector database. It lacks native vector indexing and similarity functions needed for embeddings. Using it would lead to awkward, inefficient workarounds. Therefore, it's not a fit. Why not option C? Amazon Redshift. While Redshift is a powerful data warehouse, native vector similarity support is limited compared to pgvector. It's optimized for analytic SQL over structured data, not nearest neighbor vector search. For dedicated vector workflows, Aurora with pgvector is more straightforward. Hence, it's not the best choice. Why not option D? Amazon EMR. EMR provides managed big data frameworks, Spark/Hadoop. It's a compute platform, not a managed vector store. You'd still need to build and operate storage and indexing. That increases complexity versus a native vector-capable database. Thus, it's not ideal. Question 15. A financial institution needs explainable decisions from an FM-based loan approval system. Which factor relates to explainability? Option A. Model complexity. Option B. Training time. Option C. Number of hyperparameters. Option D. Deployment time. The correct answer is A. Model complexity. Explanation. Simpler models are generally more interpretable, e.g., linear tree-based with constraints. As complexity increases, e.g., deep nets, attributing decisions becomes harder without specialized tooling. Explainability frameworks, e.g., SHAP, can help but add overhead. Therefore, complexity is directly tied to explainability. Why not option B? Training time. Longer training doesn't inherently make a model more or less explainable. It may improve accuracy but says nothing about interpretability. Explainability is about understanding decision logic, not how long training took. Thus, training time is irrelevant. Why not option C? Number of hyperparameter count affects tuning difficulty, not end-user interpretability. Even few hyperparameters can yield opaque models. The crucial factor is the functional form and structure of the model. Hence, this isn't the right lever. Why not option D? Deployment time operational rollout speed does not influence how decisions are explained. It concerns release management and SRE practices. Explainability pertains to model behavior, not deployment logistics. Therefore, it's unrelated. Keep the momentum going. Subscribe for new certification practice every week. Visit cloudcertificationstore.com for weekly releases, previews, and complete question banks. Question 16. A pharmaceutical company wants concise overviews of user reviews for medications. Which solution meets these requirements? Option A. Time series forecasting with Amazon Personalize. Option B. Summarize reviews using Amazon Bedrock LLMs. Option C. Classify medications into groups with SageMaker. Option D. Use Amazon Recognition to summarize. The correct answer is B. Summarize reviews using Amazon Bedrock LLMs. Explanation. LLMs excel at abstractive and extractive summarization of unstructured text. Bedrock provides managed access to multiple FMs that can be prompted for concise summaries. You can specify style, length, and structure to standardize outputs. This directly fulfills the requirement. Why not option A? Personalized forecasting. Personalized provides recommendation systems, not time series forecasting or summarization. It won't read free-form reviews and produce overviews. Using it here would misalign capabilities and goals. Thus, it's unsuitable. Why not option C? Classification with SageMaker. Classification assigns categories. It doesn't produce condensed narratives. It might help tag reviews, but it won't generate summaries. You'd still need a summarization step. Therefore, it doesn't meet the core need. Why not option D? Recognition processes images and videos, not text. Medication reviews are textual, requiring NLP. Applying recognition would provide no value for summarization. Hence, it's irrelevant. Question 17. A company wants lead prioritization with adjustable feature weights by domain experts. Which model type meets these requirements? Option A. Logistic regression. Option B. Deep learning using principal components. Option C. K-nearest neighbors KNN. Option D. Neural network. The correct answer is A. Logistic regression. Explanation. Logistic regression exposes interpretable coefficients for each feature. Domain experts can adjust or regularize these weights to reflect business knowledge. The resulting decision boundary remains transparent and auditable. It's a strong fit for explainable, tunable scoring models. Why not option B? Deep learning with PCA components are linear combinations of original features, obscuring interpretability. Adjusting component weights doesn't map cleanly to business features. This complicates stakeholder control and trust. Thus, it's not ideal. Why not option C? KNN has no explicit feature weights. It relies on distances in feature space. Altering weights would require custom distance metrics, adding complexity. It also performs poorly on high-dimensional, unscaled data without careful tuning. Therefore, it's a poor fit. Why not option D? Neural nets are powerful but opaque, with weights that don't map intuitively to features. Post hoc explanations are possible but add overhead and uncertainty. They hinder direct stakeholder tuning of feature effects. Hence, not the best match. Question 18. Using RAG with Bedrock plus Stable Diffusion for product images yields random, underspecified results. How to increase specificity? Option A. Increase the number of generation steps. Option B. Use mask image black mask source option. Option C. Increase the classifier-free guidance, CFG scale. Option D. Increase the prompt strength. The correct answer is C. Increase the classifier-free guidance, CFG scale. Explanation. Higher CFG increases adherence to the text prompt relative to the model's prior. This reduces drift and randomness, producing images closer to requested details. It's a standard lever for precision in diffusion models. Thus, it directly addresses specificity. Why not option A? More steps, additional steps can improve denoising quality but don't guarantee better prompt fidelity. You may get sharper images that are still off-prompt. It also increases latency and cost without solving specificity. Hence, not the primary fix. Why not option B? Mask image black masking pertains to in-painting workflows, not general text-to-image specificity. If you're not editing regions of an existing image, masks are irrelevant. Applying it here wouldn't improve text adherence. Therefore, it's not applicable. Why not option D? Increase prompt strength. Prompt strength is not a canonical stable diffusion parameter for text guidance. CFG is. Some UIs use strength to mean image conditioning vs text conditioning. The robust model-level control is CFG, making D imprecise. Thus, it's not the right choice. Question 19. Which strategy best determines if an FM effectively meets business objectives? Option A. Evaluate performance on benchmark datasets. Option B. Analyze model architecture and hyperparameters. Option C. Assess alignment with specific use cases. Option D. Measure computational resources for deployment. The correct answer is C. Assess alignment with specific use cases. Explanation. Business value depends on outputs driving targeted outcomes, e.g., conversion resolution rate. Alignment tests ground the model in real workflows and KPIs, not abstract metrics. They reveal gaps that benchmarks miss, especially domain-specific nuances. Therefore, it's the most relevant strategy. Why not option A? Benchmarks useful for general capability but often fail to capture domain constraints. High benchmark scores don't guarantee success on proprietary tasks. Relying on them alone risks misalignment with business goals. Thus, insufficient. Why not option B? Architecture/hyperparameters design choices inform capacity and efficiency but don't prove outcome fit. A well-tuned model can still be misaligned. Business impact requires end-to-end evaluation, not just technical introspection. Hence, not adequate. Why not option D? Computational resources, cost, and latency matter, but are secondary to outcome effectiveness. A fast, cheap model that fails objectives still delivers poor value. Resource measures should be balanced after confirming alignment. Therefore, not the primary determinant. Question 20. A company has a large labeled dataset of animal images and will not label more data. Which learning type should it use? Option A. Supervised learning. Option B. Unsupervised learning. Option C. Reinforcement learning. Option D. Active learning. The correct answer is A. Supervised learning. Explanation. Supervised learning maps images to known class labels, matching the classification task. With labels already available, it is the most direct and effective approach. It enables standard evaluation metrics accuracy, F1, and controlled iteration. No further labeling is required for model training. Why not option B? Unsupervised learning clusters or embeddings won't guarantee alignment with known species labels. Post hoc labeling adds complexity and reduces control. It's better for exploration than for targeted classification. Thus, not suitable. Why not option C? Reinforcement learning (RL) optimizes actions via rewards in interactive environments. Image classification doesn't provide sequential decision rewards. Using RL here adds unnecessary complexity. Therefore, it's a mismatch. Why not option D? Active learning focuses on selecting new samples for labeling to improve models. The premise says no new labeling will occur, so AL's value is limited. It adds process overhead without benefit under these constraints. Hence, not appropriate. That wraps up this episode. Follow the channel for more certification practice videos and share this one with someone who could use the extra exam preparation. The next episode continues the question set.